Greetings, math fans. Alright, so this is really kind of a continuation of day one, and I just wanted to show you a couple more examples and show you some of the pitfalls and just give you a little bit of advice on how to deal with radians. Okay, radians is really not too difficult. And it's just another measurement. Instead of using angles, we're going to be using radians. Alright, so one thing that I think is really important to mention here is if I ask you to convert, and people sometimes want to do coterminal. So if I give you like 7 pi over 3 and I ask you to convert to degrees. Guys, you do not rewrite this. You don't go, oh, I need to do coterminal and bring it back to something smaller. You're going to do a direct conversion. So it's 7 pi over 3 times 180 degrees over pi. Okay, so the pi's cancel. That's a 1, and that's a 60, and so we get 420 degrees. Okay, it's really easy, but don't do coterminal. It's a very, very bad thing to do, because now if I'm actually taking the sine, so let's actually do that. If I said, hey, what's the sine of 7 pi over 3? Then you want to do coterminal. Okay, because now I want to actually get something that's more reasonable. I want to get something that's between 0 and 2 pi. All right, it's important. So here I would actually say, doing coterminal. Remember, guys, that is adding or subtracting 2 pi, and it's increments of 2 pi. So n is an integer. Okay, and remember, 2 pi can be 12 pi over 6. It can be 8 pi over 4. It can be 6 pi over 3. Okay, and even 4 pi over 2, right, if we're talking about one of the quadrantiles. That's important. You can add and subtract that because that's truly what 2 pi is. All right, so just to kind of continue with this problem here, if I would subtract 6 pi over 3, that would give me sine of pi over 3. Well, that's pretty sweet. That's actually a really easy one because sine of pi over 3, right, isn't that 60 degrees? Sine of 60 is 1/2. So that means sine of pi over 3 is also 1/2 when we're in the first quadrant. Okay? So let's just talk about, let me just draw this picture here. And I did this already on the first part of the video. But this is going to be 0 radians. This is pi over 6. This is pi over 4. This is pi over 3. This is pi over 2. Okay, and then we have one of these in each one of those quadrants. So I'm going to draw 3 additional ones in each quadrant. And this is the way it goes around, math fans. Okay, so just kind of pay attention here. This is pi over 6, which we already talked about. That's pi over 3. So I'm going to ignore the pi over 4. In fact, you know what? Let me do the pi over 4 first. That's pi over 4. Do you guys agree pi over 2 is really 2 pi over 4? And this is 3 pi over 4. And this is 4 pi over 4, or pi. This is 5 pi over 4. This is 6 pi over 4, or 3 pi over 2. This is 7 pi over 4. And this is 8 pi over 4, which is, of course, 2 pi. Okay? So that does the pi over 4s. That's like kind of each quarter of the way around. So let's do the pi over 6s. This is pi over 6. This next one right here is 2 pi over 6, which is pi over 3. And then, excuse me, 3 pi over 6. This is 4 pi over 6, which is reduced to 2 pi over 3. 5 pi over 6. 6 pi over 6, which is pi. 7 pi over 6. 8 pi over 6, which is reduced to 4 pi over 3. It's 8 pi over 6, 9 pi over 6, which actually is 3 pi over 2, 10 pi over 6, which is 5 pi over 3, and then 11 pi over 6. Okay, so those are all of them around there. Now, do you have to memorize all those? No. But what I want you to understand is, see how I wrote this 8 pi over 4 is 2 pi? Well, that's also 12 pi over 6, and that's also 6 pi over 3. Okay? And the reason I'm telling you this is because when you are given a value, and after you subtract the 2 pi's from it each time, right, to bring it down to something more reasonable, you're gonna look at it as opposed to going and converting it using your conversion to get to degrees. You're actually going to think about it like if I told you 11 pi over 6, you should think to yourself, wow, that's really close to 2 pi. And if 2 pi is over here, that means I'm in this quadrant. That's what I want you to think of. Now, the reference angle, remember, is like super easy. If I give you pi over 6, you know the reference angle is 30. If I give you pi over 3, reference angle is 60. And if I give you pi over 4, the reference angle is 45. Okay, that's like really, really easy. It's really thinking of the quadrants you're in. That's actually the hardest part of this whole thing. So, again, 11 pi over 6, I know I'm in the fourth quadrant. If I gave you 5 pi over 6, well, isn't that almost 6 pi over 6, which is right here? So it's a little bit less than that. If it was 7 pi over 6, isn't that a little bit more than 2 or than pi? So we're in the third quadrant. Okay? So that's why it's kind of helpful. Here, let me just give you a couple other random ones. 4 pi over 3. Well, isn't that a little bit more than 3 pi over 3? So we're in the third quadrant again. How about 5 pi over 4? Well, isn't that also in the third quadrant? Is that a little bit more than 4 pi over 4? And here, how about this one? How about 7 pi over 4? Well, isn't that a little bit less than 2 pi? So isn't that going to be in the fourth quadrant? Okay, so hopefully you guys kind of get the gist of this a little bit, where to locate things. Okay, because again, if you had to multiply by pi over 180 or 180 over pi in this case to convert it to degrees, it would take you a long time. I want you guys to start realizing where things are. All right, but again, remember to do coterminal, it's plus or minus 2 pi, and you know what 2 pi is for each one of the special reference angles. Okay, so let's actually do a couple different problems here. I'm just going to make some up. I'm going to say tangent of, let's do 23 pi over 6. All right. Now, if you look at it, 23 pi over 6, isn't that really close to 24 pi over 6, which is 2 pi? Okay, but I'm going to subtract from this. How many 2 pi's can I subtract? Well, remember it's 12 pi over 6 is 2 pi, and I can only do one of those. Do you guys agree with that? Okay, because if I do one, I get 11 pi over 6. So my new problem is really tangent 11 pi over 6. Okay? Now, right away, there's my reference angle. It's really pi over 6, or as you guys know it is 30 degrees, right? And of course, what's the tangent of 30? Well, 3's rule there, so isn't that root 3 over 3? Okay, so that's half the battle. The other battle is to know what quadrant we're in with 11 pi over 6. Well, again, 11 pi over 6 is 2 pi. It's a little bit less than 2 pi. So doesn't that mean I'm like right over here? And what's tangent here? Right? All students take calculus. Isn't tangent negative there? So the answer to this problem, the original problem, tangent of 23 pi over 6, is negative root 3 over 3. Okay? So here's a couple steps to just to refresh what I just did here. Did coterminal to bring it back to something reasonable. Okay? And then I looked at the bottom number here, got my reference angle, and then I said, okay, now the number that brought it back down to, which was 11 pi over 6, what quadrant is that in? Oh, it's in the fourth quadrant. What is tangent? It's negative, so that's why I have negative root 3 over 3. Okay? So let's try another one here. How about the sine of 29 pi over 4? Okay. Well, I'm going to subtract 2 pi, multiple 2 pi's, which is 8 pi over 4. And how many 8's go in? Basically, you're saying how many 8's go into 29? Well, isn't it 3? So can I multiply that by 3? So I really have the sine of, do 24 pi from 29 is 5 pi over 4. That's really my new problem, math fans. sine of 5 pi over 4. All right, sine of pi over 4, the reference angle is that 45 degrees, sine of 45, that's root 2 over 2. Okay, cool. So I already have half my answer. I just need to know the sign, S-I-G-N. And 5 pi over 4, isn't that a little bit more than pi? So we're down here. So that means my answer, again, all students take calculus, so sine is negative. So the answer to this problem was negative root 2 over 2. Okay, that's not bad. Let's try negative one. How about cosine of negative 31 pi over 3? All right, well, I'm just going to start adding 2 pi or 6 pi over 3. Right, I want to make that positive angle. So it looks like 6 goes into 30, isn't that 5 times? So I really need to add 6 of them, right, to bring it to positive. So 6 of these. So that's saying negative 31 pi plus 36 pi. That gives me 5 pi. So there we go. My new problem is now cosine of 5 pi over 3. Well, what's cosine of pi over 3? So that's 60 degrees. What's cosine of 60 degrees? It is 1/2. So my answer is 1/2. I need to know the sign. Where's 5 pi over 3? It's almost 2 pi. So we're right here. And it's all students take calculus. So it's positive. So my answer, is positive 1/2. All right. Let's try another one here. How about cosecant of 17 pi over 4? Okay. And, well, we're going to subtract 8 pi over 4. And, in fact, 8 goes into 17 twice. That's the maximum. So it's really 17 pi minus 16 pi, which is just pi. Oh, that's kind of a nice one. So I really have cosecant of pi over 4. That's an equivalent to it. Okay? And if you're not good with cosecant of pi over 4, you can always do 1 over the sine of pi over 4. Remember, don't do this. This is crazy. Okay? Boo! Don't do that. So it's 1 over that. So what's sine of pi over 4? Isn't that root 2 over 2? If I rationalize, right, I get 2 over root 2. And of course, some of you guys already know this already, 2 root 2 over 2, which is just root 2. Okay, and it's positive. That's kind of a nice one, right? So the answer to that problem is just root 2. Okay, let's try one more here. We'll do secant of negative 41 pi over 3. Okay, looks super nasty and complicated, but we're just going to add to that 2 pi, which is 6 pi over 3. And how many of those can I add? Well, if I do 6 of them, it's 36. If I do 7 of them, it's if I do 7 of them, right, it's going to be 42. So that's what I want to do. I want to do 7 of those. So negative, basically saying negative 41 plus 42 is 1. So my problem is now just pi over 3. That's actually a lot easier. All right. Of course, secant goes with cosine. So and then it's 3. So it's in the cosine of pi over 3. It's 1 over that, right? Cosine of pi over 3 is 1/2. So it's 1 over 1/2, which is 2. All right, and of course we're in the first quadrant because pi over 3 is here, so the answer is positive 2. Okay, let's just try another one. It's just good practice. I mean, you don't have to watch this whole video, but you know, if you want to just do a little more practice, that's cool. Let's do the cotangent of negative 28 pi over 3. Yeah, that looks good. Okay, so we've got to do 6 pi over 3. Add and subtract that, right? And if I think how many 6's go into 28, 4, but then you got to do 5 to bring it up to make it positive. So it's plus 5 times 6 pi over 3. And that gives me cotangent of 2 pi over 3. Okay, not too bad. Reference angle's pi over 3, so it's 60 degrees if you want to think of it that way. And what is cotangent of 60 degrees? That is going to be root 3 over 3. Okay, and you know, if you're not remembering that, you can always do 1 over tangent. Remember, tangents rule at 30 degrees, so cotangents rule at 60 degrees. I don't know how you remember that, but anyways, root 3 over 3. And then 2 pi over 3 is over here, which is a little bit less than pi, a little bit less than 3 pi over 3. And so that's going to be, right, all students take calculus, and so that's going to be negative. And that's the answer to that problem, is negative root 3 over 3. All right, so let's say I gave you a few more practice problems here, a little bit more of an idea of what you need to add and subtract to kind of think of things. But just remember, everything, you know, especially the your special angles in terms of pi and 2 pi, I think it really helps out a lot. All right, that's it, math fans. Have a good day. Adios. Goodbye.